What's up, guys? So today we are going to be doing the quick sort. Quick sort can be kind of difficult for some people to understand, and then at the same time it does require a little bit more of complex type subjects, especially because it does use recursion. But I'm going to go ahead and try to explain to you as best as possible. So if you kind of get lost, just stick with it. I'll try my best to explain it better as we go along. So for quicksort, there's a lot to it. So I'm going to try to, well, let's just get started. Okay, so for quicksort, what we're going to do is, let me go ahead and just get rid of this for now, because I'm going to need this space. And so for quicksort, what we want to do, hold on, that is an 8, is we have this list of numbers, 4, 1, 3, 8, 2, 7, 5, 6. And what we're going to do is we're going to check the leftmost numbers, or the leftmost index. So if this is index 0, 1, 2, 3, 4, 5, 6, 7, and we're going to check the lowest possible index, and we're going to use that as something called a pivot. Some people will use the middle number, some people will use the rightmost. For this example, I'm going to use the lowest possible index. So in this case, it's this 4 right here. Okay, so now what we're going to do is I'm going to check all the numbers to the right of it, and I'm going to check, is it less than or greater than the pivot, which is 4. Let me go ahead and write that, pivot. Okay, if it is less than, I'm going to check if there's any items between it that are greater than, and swap. It'll make sense if I do it. So is 1 less than or greater than 4? It is less than. Is 3 less than or greater than 4? It is less than. Is 8 greater than or less than 4? It is greater than. And 2 is less than or greater than 4? It is less than. And now I want to point out something. So whenever we have a greater than, or whenever we hit a less than, we actually have to check if there are any greater thans. If there is, we're going to go ahead and perform a swap. So for this case, we're going to swap the 2 with the 8 because it is the closest greater than. So I'm going to swap the 8 and the 2. And again, 2 is less than and 8 is greater than. Okay? Is 7 less than or greater than 4? It is greater than. 5, of course, is greater than, and so is 6. Now, the next part of quicksort is we're going to go ahead and count how many less thans there are. 1, 2, and 3. So we're going to swap the pivot 3 spaces over. So we're going to swap it 1, 2, and 3. We're going to swap it here. So I'm going to go ahead and put the 2 here, where the pivot used to be. And the 4 is going to go here, but I'm going to do something that's going to look kind of odd, but it'll make sense as we go along. So I'm going to go ahead and put the 4 way up here, but it's still in that position. Okay, so if this were an index, so it would be index 0, 1, 2, 3. It would still be in the 3rd index. Okay, so now the 4 is in fact locked in place. And the reason that I do it this way is because when you use the recursive method in order to kind of iterate through this entire array, you're going to be checking the left of the pivot and the right of the pivot. So first you will check all the items to the left, and then you will check all the items to the right. So for instance, in this case, what we're going to do is we're going to go ahead and check all the items that we haven't checked to the left of our newest pivot, which is the 4. And in this case, like we did in the first time around, the lowest possible index of items that we haven't checked, 0, 1, and 2, the lowest index is 0. So this will be our new pivot. Pivot. Okay, and again, we're going to just follow the same pattern that we did last time. Okay, is 1 less than or greater than 2? It is less than. And is 3 less than or greater than 2? It is greater than. How many items are less than 2? There is 1 less than, so we are going to swap it 1 place over. Okay, so let's go ahead and swap it. So the 1 is now going to go here, and the 2, again, just like we did last time, the 2 is going to go into this location here, but I'm going to write it way up here. So it's going to start to look like a tree. Okay, and so now the 2 is locked in place, and I'm going to go ahead and represent that with this line here, but it's still in the 0, 1 index. Okay, and now just like we did for the 4, we're going to go ahead and check all the items to the left of the 2 and then all the items to the right of the 2. Okay, so let me go ahead and just get rid of all these greater than symbols and clear this up real quick. So now again, we're going to check the lowest possible index of items we haven't checked yet. In this case, it's just the 1. So it's the 0 index, it's just the 1. And the way that this is going to work is I'm going to check how many items between this 1 and a locked-in number are less than or greater than 1. In this case, there are 0 items, therefore we are going to swap it 0 places over. So it's in the correct index. And then what happens is, again, just like I did with the 4 and the 2, I'm going to go ahead and lock it in place with this, and then I'm going to check all the items to the left of the 1, and then all the items to the right of the 1. And as you can see, there aren't any items here. So we're done checking all the left of the 1. And then there aren't any items to the right of the 1. So we're going to go ahead and say that this is done, and therefore we have now finished all the items to the left of the 2. So now we have to check all the items to the right of the 2. And in this case, it's just this 3. So from 3, which is now our new pivot, we're going to go ahead and check how many items from here until we hit a locked number are less than or greater than 3. And in this case, there are no items which are less than or greater than. And because we have no less thans, we are going to swap it 0 places over, which means it's in its correct spot. And I'm going to go ahead and represent it by this. And then we have to check all the items to the left and the right of the 3. And as you can see, between the 2 and the 3, there are no items unchecked. So we are done checking the left side of the 3. And there are no items unchecked between the 3 and the 4. So we are done checking all the right side, which means we are now also done checking all the right side of the 2. And then we've checked all of the left side of the 4, so we're done with the left side entirely. But now we have to focus on the right-hand side of the 4. And again, we have to ask, what is the smallest possible index of items we haven't checked? So if this was 0, 1, 2, and 3, the lowest possible index is going to be this 8. So 8 now becomes our new pivot. Okay, and so we're going to check all the items to the right of 8, all right, until we hit the end of the array or a locked in place number, in which case there is none. So let's go ahead and check. Is 7 less than or greater than 8? It is less than. And of course, 5 is less than, and 6 is also less than. So let's count how many less thans there are. In this case, there are 1, 2, and 3. So we're going to go ahead and bump it over, or I should say, swap it 3 places over. So 1, 2, and 3. So we're going to swap it with the 6. So the 6 now comes here. And again, just like we did with all the other numbers, the 8 is going to come here, but I'm going to go ahead and write it up here. Okay? And now the 8 is now locked in place. So we're going to go ahead and do this. And now, let me kind of clean this up a bit. Now we're going to go ahead and check all the unchecked numbers on the left and the right of 8. So now, what is the smallest possible index of items we haven't checked? In this case, it's going to be this 6 again. And now, or I shouldn't say again, but now it's going to be this 6. So this 6 is our new pivot. And so for the 6, we're going to check all the items that are less than or greater than 6. So 7 is greater than, and then 5 is less than. And again, whenever we hit a less than, we check if there are any greater thans between the less than and the pivot. In this case, there is a 7, so we're going to go ahead and swap the 5 and the 7. And now that the 5 is less than, and the 7 is greater than. And now that we have finished checking all the numbers, because we now hit this locked in place number, now we're going to ask how many are less than. In this case, there is 1 less than, so we are going to swap it over 1 place. So the 5 now comes here. And the 6, we're going to go ahead and put it in this position here, but we're going to write it up here. And the 6 is now locked in place. And now we're going to check the left side of 6, and then we're going to check the right side of 6, which is just 7, okay? So now for the 5, we're going to go ahead and, we're going to go ahead and check the lowest possible index that we haven't checked. In this case, it is this 5. And now we check all the items to the right of it until we hit the end of the array or a locked in place number. In this case, it's the 6. And we're going to check how many are less than 5. There are 0, so we're going to swap it over 0 spaces, which means 5 now becomes locked in place. Okay? And then again, because it's our new pivot, we have to check the left and the right of 5. So on the left of 5, as you can see, there are no numbers that are left unchecked. So we are done with the left side. And now, if you look at the right side of 5, there are no numbers between 5 and the other locked in place number 6 that are unchecked. So we are done checking the right side of 5, which also means we're now done checking the left side of 6. So now we have to check the right side of 6. And the only number that we haven't checked is 7, or this 7 position. So now we have to go from 7 till we hit a locked in place number and check how many numbers are less than or greater than 7. In this case, it is going to be 0. There are 0 numbers, so we are going to swap it over 0 places. So now the 7 is now a locked in place number. And now we have to check all the items to the to the left of 7, and then all the items to the right of 7. So in this case, there are 0 items to the left. There are 0 items unchecked at the right, and which means we are done checking all the right items of 6. And since we're done checking all the right items of 6, we are now done checking all the left of 8. Sorry, this should be a 7. And now we have to check all the items right of 8. And as you can see, there are none. So we're done checking the right, and that ultimately means we are done checking the right of 4. I know this looks kind of funky, but this is how I can best show you that after every time we swap, we always have to check the remaining left and right. And so it kind of looks like this tree, and ultimately what you get at the end of this is this array here. So this would be 0, this would be 1, this would be 2, 3, 4, 5, and 6, and 7. These are the indexes. So therefore, if you look at the array, is it sorted? And we can check 1, 2, 3, 4, 5, 6, 7, and 8. It is in fact sorted. So again, this is how quick sort works. And I know it can be kind of difficult to kind of wrap your brain around. But in other words, you're always going to pick a pivot, and then you're going to search the left of the pivot and the right of the pivot, and it's going to work kind of backwards like a tree. You're going to check left, check left, check left, check right, check left, check right, check left, and again just continue over and over until it is complete. And again, that is quicksort. If you have any questions, feel free to leave a comment, and I'll try my best to answer any.